Okay, welcome back everyone. So in this short video, we're going to just do a brief introduction to assembly language. Really the goal is to let you know what it is, why we care about learning about it, and I think the best way of introducing this is to think of an analogy, because an analogy in this case can, I think, make it very simple of kind of what we're getting at. And it just makes it less abstract and kind of foreign. So let's just jump right in here, and let's think of kind of the following scenario. Okay, let's imagine we've got somebody here who's like let's kind of consider a worker bee, right? Somebody who is just doing what's told, kind of working away, getting a job done. And this worker only speaks English, right? Only language that if you're telling this employee or this worker bee what to do, and it's following these instructions, this worker can only understand and operate in English, okay? So let's take that as the scenario. Okay, and let's imagine that this poor person has multiple managers telling them what to do. Okay, and each one of the managers speaks a different language. Okay, maybe French, German, and Chinese. Okay, whatever it happens to be, and maybe that's the only language that each one of these managers speaks. Well, then obviously for this to work, we've got to go through some sort of middle layer. Okay, we've got this middle layer here, and this middle layer needs to translate the instructions coming from the manager, all right, into the language that the worker bee can understand. Okay, and what we can have is we can have this one worker, right, can be commanded from people speaking different languages as long as there's a middle layer doing the translation. Okay, now that seems probably a pretty straightforward idea. Right? And I'd like that kind of straightforward idea to stick with you because it's really no different than something that's going on when we're compiling a program. Okay? What we have in this case is our worker bee is our processor, our central processing unit, our CPU. Okay? And this CPU speaks a particular language. Right? We're going to call this language the instruction set. Okay, the instruction set. I'm going to come back to that momentarily, right? You kind of put in the back of your mind the idea that the language that this processor speaks is an instruction set. Okay, different processors have different instruction sets, so they speak different languages, right? They can operate on those instructions that they can understand and process, right? We'll spend a decent amount of time looking at a particular instruction set and looking at how it works and even seeing how it's processed. Okay. Now, you're not coding directly, or very rarely is somebody coding directly in the language that the processor speaks, the instruction set that the processor speaks. And the reason for that is it's not something that's really in what would be considered a easily human readable form. All right, it's ugly. Right? It's really, really ugly. It's hard to be very productive if you're operating in it. Okay. We'll kind of look at this in terms of two different ways. We'll talk about something called assembly language. We'll spend a lot of time getting some practice in that and experience with that. We'll also talk about machine language as well. And machine language is effectively in binary. It's ones and zeros. Okay. And if you take the example of ones and zeros, right? Imagine you're trying to code a program, a complicated program, and you're setting thousands or millions of ones and zeros and having to lay them out a particular way because that's what the processor understands, right? You're not going to be very productive, okay, doing it that way. So we obviously don't really want to build systems doing that. What we want to do is we want to write in some higher level code, right? I just put some examples in here. We're going to talk about C programming, which we'll do quite a bit in this class. Other languages, just an example, Fortran, Pascal. I mean, there's tons of languages over the years, okay? And somebody can code in any one of these languages, okay, and they can all run on this same underlying processor, even though the language that the programmer is coding in is different than the language that the processor actually knows, the instruction set that the processor knows. And why? Well, we're effectively translating it, right? We're going through the compiler. The compiler is taking that higher level programming language, right, and compiling it and translating it into something that hardware can understand and can actually run and process. Okay, so it's a very similar idea that we talked about here with translating one language into another. This is effectively what's going on. Now, this is a high-level overview. We're going to get into more detail throughout the course. Right? We're going to you will build a small mini compiler okay, as part of the course. You're also going to build a small mini assembler as well, which we haven't really talked about exactly what an assembler is yet, okay? And we'll do things like, well, we'll code and get things working in assembly language. We'll look at what is assembly language, get some practice using it. We'll also look at machine language, those ones and zeros, right? And we're going to get some practice doing that as well, okay? Now, effectively, what's going on here, right? I mentioned that the processor is designed to run on a given instruction set, okay? This is the commands or the instructions that the processor knows what to do with. It's kind of, and effectively, it is the interface between some portion of code and the processor that they can then actually do something with it, okay? So an example of an instruction could be like add two numbers and store the result somewhere, okay? So the processor is designed to support a certain number of instructions that are doing some different things, okay? And what effectively we have here is we're going to take, we're kind of examining a little bit deeper in terms of the steps along the way of what's happening. But we have our higher level program, let's just say it's in C, okay? We compile that. When we compile that program, right, the compiler actually puts it into something called assembly language, okay? This middle layer here is assembly language, okay? All right, and there's actually one more step called the assembler, in which we're taking the assembly language and actually then converting it into ones and zeros, okay? So this middle layer here, this assembly language layer, this is considered the closest to the ones and zeros that we can kind of get, where humans have the ability to kind of write code in it and understand it, right? Once you start going into large numbers of ones and zeros, our brains just can't operate that way, right? It's just, it's too detailed, too cumbersome. There's too many ones and zeros to make sense of it, okay? It's not like the Matrix where you can just look at all the code or the ones and zeros on the screen and immediately see what's going on, if you know what I'm talking about from that movie. But assembly language, as we've seen, right, or as we will see, is we'll get some practice using it. We'll build things. We'll write code directly in it. Is human readable, even though it's very close to the underlying hardware. It's just really, really close to the underlying ones and zeros, and there's a really clear conversion between one and the other. All right, more on that later. Okay, but essentially what you're seeing is a hierarchy, right? The higher level languages, the term higher level is coming from higher level, meaning it's easier for the programmer to get stuff done in it, right? It's more abstract from the underlying hardware. It's further away from the ones and zeros, right? It's easier to get something done because you don't have to worry about all the details, okay? Lower level, like machine language, is where you're in the nitty gritty, you're in the weeds. It's exceptionally hard to be very productive doing something very low level, right? But there's times based on different problems and different things that you're working on that you're at different levels of being something very high level or very low level and detailed oriented, okay? And we can kind of see that in this picture here, right? You can think of it, the foundation is you've got the hardware, right? The hardware understands machine language, the ones and zeros. A little bit above the ones and zeros, we're going to see something called assembly language. That's really, there's a clear conversion between the ones and zeros in assembly language. We go further up when we have our higher level languages. This is something that you really can get a lot done and program with, you know, your C language, etc. Okay, and there's actually, even in those different languages, there's different ones that are considered more higher level languages than others. Okay, sometimes people will refer to C as a mid-level language because it still has some ugliness to it and some real into the weeds details as well. Okay. All right. My goal in this video is not to give you all the information, right? We're going to do that. It's going to take time, right? But I just give you the perspective of what these different terms are, right? Things like instruction set, compiler, and assembler, right? We'll spend time understanding this compilation process of compiling something all the way from the higher level language all the way down to a machine language executable. We'll see all the detailed processes in between. We're actually skipping some details here, right? But we will do that incrementally over time throughout the early part of this semester, okay? Well, one of the things that we're going to do early in the semester is we're going to spend time doing writing assembly language, okay? And I will follow up shortly where we actually start seeing our first assembly language programs. But it does make sense to just take a moment and say, well, why? Why do we actually want to code an assembly language to begin with? Okay, and I'm going to just I'm going to mention what I consider by far the best reason right away, and just emphasize this up front. One of the best reasons to code an assembly language is it gives you an understanding of how the processor and memory work, right? How they work together and how programs are then executed. Okay, what we want to do is understand how processors are architected, right? We're going to look at a particular processor, ARM processor, right? That's if you've got an Android phone, that's in your Android phone. If you used a Raspberry Pi, that's the processors in the Raspberry Pi. There's literally been billions of them produced. We're going to look at an ARM processor, and we want to get an understanding of how the processor works, okay? And it's very hard to have that understanding if you don't understand assembly language, right? AKA understanding the instruction set, the instructions that underlying hardware supports, right? We need to understand how we can tell the hardware what to do before we can really understand what the hardware is actually built and how it actually works. Okay, so understanding is one of the fundamental and in the most important reasons. Okay, that being said, there are some additional reasons as well. Okay, and a lot of them have to do with optimization. Okay, sometimes, right, if there's an extremely high degree of optimization control needed, people will code directly in assembly language. Okay, not that often, but it does happen. Right, and having an understanding of doing any sort of direct hardware manipulation. You want to do something really, really detailed and tell the hardware to do something very specific, and it kind of connects with the optimization issue. Things like something doing real time, right? Even like device drivers, right? We're going to deal stuff with embedded systems in here in the latter part of the course. All of that stuff, right? Having a knowledge of assembly language is helpful. Okay, where we're heading, right? Down in some weeks from now, we're not going to get there right away. We're going to start looking at diagrams like this, okay? And this is effectively getting a logical view of different components of a CPU, of a processor, where we have memory, we've got some fast cache registers, and all these different parts of these processor. And we're going to see how we take instructions, right? We're going to see how the software interfaces with the underlying hardware. And I think it's very fascinating, because it bridges two worlds that you've kind of started seeing in other courses, right? You've done courses related to programming, so you're in the software world, and then you do courses that are more like your circuits, your digital systems courses that are really in the hardware or circuits realm. And you're seeing as these worlds kind of come together and intersect, right? And we're going to get to that point this semester in this class. And I think it's a very interesting topic. I'm biased. I like teaching it, right? I hope you like it as well. But there's a reason why we are learning these things, why we are learning assembly language and everything, is if we want to understand processors, if we want to be able to understand how they're architected, built, and designed, right, we have to understand the interface to them. We have to understand the instruction sets and how they connect, okay? And we will start seeing that in a subsequent video looking at doing some of our first assembly language programming. Okay, but I will see you in a future video, and I will also see you in class.